ever been coding in Java and just wished you could create a super specific error for a very specific problem? Well, you're in luck. Today, we're diving into exactly how to do that by creating your own custom exceptions. So let's kick things off with a question that probably sounds familiar. You're building an application, things are going great, but then you hit a snag. Java has all these standard exceptions, like null pointer exception or IO exception. But what happens when they just don't fit? What if they don't really describe your application's problem?
Think about it. If you're making a banking app, how do you signal an insufficient balance error? Or what about a registration form? How do you flag an invalid age? These aren't low-level system problems. These are about your business logic.
That's exactly what we're covering in this explainer. We're going to walk through how to build your own custom exceptions to handle these kinds of real-world scenarios. The goal? To make your code way clearer, more specific, and a whole lot easier to maintain. Okay, first things first, let's really nail down the problem we're trying to solve here. Using a generic built-in exception for a very specific problem, well, it's a common trap and it's a bad fit. Take a simple age check, for example.
So look at this. On the left, we're throwing an arithmetic exception. I mean, sure, it works, it'll stop the program, but the name of that exception has literally nothing to do with someone being underage. It's just confusing. Now look at the right. Invalid age exception. Bam! Instantly, anyone reading that code knows exactly what went wrong. That clarity is everything.
So, how do we get from that vague error to a really meaningful one? Let's get our hands dirty and build out this pattern. It's simpler than you might think.
It really all boils down to just 3 steps. First, you define your new exception as a class. Second, you declare that your method can throw this new exception. And third, when the error actually happens, you throw it. Define, declare, throw. All right, step 1, defining the class. All you do is create a new Java class, and here's the magic part, it extends the built-in exception class. Now, by extending exceptions specifically, you're creating what's known as a checked exception. And this is so important. It means the Java compiler will actually force any code that calls your method to deal with this potential error. No more forgetting.
Let's look at the actual code, because you'll see just how simple this is. We've got our class InvalidAgeException, and the key is extends exception. Inside, we just have a constructor that takes a message, then it uses the keyword super to pass that message up to the parent exception class so it can be stored. And that's it. Seriously, you've just defined a custom exception.
Okay, so we've defined it. Now we need to use it. This involves 2 keywords that sound almost the same but do totally different jobs. Throws with an S at the end, and throw. You use throws in the method signature. It's like a warning sign. Then, inside your logic, you use throw to actually launch the exception. And here's what that looks like in practice. See the method signature? Right after checkAge int age, we add throws invalid age exception. That's our warning label. Then, inside the if block, when the age is too low, we use throw new invalid age exception and give it a helpful message. See how that works? Our error handling now perfectly reflects our business rule. The final piece of the puzzle is actually handling the error. Because we made a checked exception, any code that calls our checkAge method has to wrap it in a try-catch block. This is amazing because it forces the developer to stop and think, okay, what should I do if the age is invalid? It makes the code so much more robust. Right about now, you might be thinking, okay, I get it, but that seems like a few extra steps. Why go through all that trouble instead of just using a built-in exception and calling it a day? Well, the answer is all about the real-world advantages. This isn't just about being neat and tidy. It's about fundamentally making your code better, and believe me, making your life as a developer so much easier down the road. Here's the real payoff. Custom exceptions let you create errors that are specific to your world, your application's domain. This makes your code so much more readable, especially for the next person who has to look at it, which might be you in 6 months. It enforces your business rules at a deep level. And all of this makes debugging a walk in the park because the error itself tells you exactly what business rule was broken. And D-Zone puts it perfectly. When you create exceptions that reflect your application's business logic, you make your code more readable. It's basically a form of self-documenting code.
Now, let's talk about a really critical design decision you have to make. So far, we extended exception, which created a checked exception. But you have another choice. You can extend runtime exception, which creates an unchecked exception. And this choice,
it has some pretty big implications. Okay, let's break this down. A checked exception is like a require field on a web form. The compiler forces you to deal with it. You use these for predictable problems that are outside of your code's direct control, like a network failing or a file not being there. An unchecked exception, on the other hand, is for programmer errors, plain and simple bugs, like a null pointer exception. The philosophy is that you shouldn't be trying to catch those, you should be going back and fixing the bug that caused them.
All right, to wrap things up, let's go over 4 best practices. If you follow these, you'll be creating custom exceptions like a pro.
Here are 4 quick rules to live by. 1, don't overdo it. Only create a custom exception if it really adds new, useful information. 2, always end the class name with exception. It's a universal convention. 3, document it with JavaDoc. A simple comment explaining what the error means goes a long way. And 4, here's a pro tip. Provide a constructor that can accept the original cause. This lets you wrap a lower-level exception, which is a lifesaver for debugging complex problems. Okay, time for a quick challenge. Go ahead and pause for a second and just think. How would you design an insufficient balance exception? What would that class look like? What kind of information would you want to include in it, besides just an error message?
So let's recap the big idea here. Custom exceptions are this amazing tool that lets you perfectly align your error handling with your application's business logic. And that alignment is the secret to making your programs more structured, more readable, and just way easier to maintain over time.
And that leaves us with one last thought. We know how to create and handle these awesome specific exceptions, but in a big application, you could end up with try-catch blocks all over the place. So the next logical question is, how can we centralize this logic so we aren't repeating ourselves? We'll dig into that next time.